Hello, hello, hello. So, last lesson in the functions unit. We're looking at inverses of a relation still. Just to review what we discovered in our last lesson, lesson 6. We discovered to find the inverse of a function, because this summarizes it really well. We want to reverse the coordinates in a set of ordered pairs, so you switch x and y. Or graphically, reflect the graph in the line y equals x. Or if we have an equation, switch x and y in the equation and then solve for y. There we go. Okay, the other thing that's important to remember is the domain of the inverse is the range of the original. Vice versa, the range of the inverse is the domain of the original. And the inverse of a function may or may not be a function, and you can test that with the VLT, the vertical line test. Okay, so these are probably the most important things to remember about inverses, or the summary of those notes right there. Okay, now we're going to skip the next section and we're going to go to the next page. Okay, and we're looking at using function notation to write an inverse. So if a function f of x has an inverse, which is also a function, then the inverse is denoted by this notation, f to the negative 1 of x, read as f inverse of x. If the inverse of a function is not a function, then the notation f to the negative 1 of x should not be used. Instead, it should just be kept in x equals f at y notation. Okay, some textbooks don't make that distinction, but we are going to. We're going to, if it is a function, we'll use this notation. If the inverse is not a function, we stick with x equals f at y. Okay, let's take a look at some steps. So this just reviews the steps. We added on one more step here, and that's check and see if it's a function at the end, and if the inverse is a function, we use this notation. Okay. So, please note that negative 1 exponent does not mean 1 over f, okay? It's not really an exponent, that's why. It's basically just a way to write that, I guess. It's a symbol is what you want to view that as. Okay, so let's take a look at this first example. Determine f to the negative 1 of x, or f inverse function of x, for the following. Okay, so first of all, our first step is to switch x and y, right? But we want f of x, or we want y, not f of x. Okay, so we replace f of x with y, and then rewrite the rest of the equation. Now we're on to actually finding the inverse. To find the inverse, y becomes x, and x becomes y. So it now is x equals 2y minus 3. Next step, we want to solve for y. So we have to isolate this y term. First thing to do that, we're going to add 3 to both sides to eliminate the subtracting 3. So x plus 3 equals 2y. Okay, and you can write that plus 3 underneath if you like to show doing that. Okay, finally, we want to isolate y, and we're going to have to do that by dividing both sides by 2. Okay, so we would have y equals x plus 3 all over 2. And we can leave it written like that, the right-hand side there. Now finally, last step is we want to replace y with this notation, the inverse function notation, as long as this is a function. Now, do you guys recognize that function? It is a straight line, okay? It would probably look, something like this. But to confirm that, you can put that in the calculator to confirm that this would be a line like that. Vertical line would only pass through it once, so therefore we can use our function, our inverse function notation. So that replaces y, and there we go. There's our answer. Okay. Yeah, let's try that. Actually, you guys try B, and then we'll check back and see if we have the same answer. Pause your video. Okay, so the answer I arrived at is y equals the cube root of x minus 4. So we made f of x into y, switched x and y, isolated y by subtracting 4 from both sides, and then finally getting rid of the cube on the y by cube rooting both sides. Okay, now the question is, there might be one more step, as in, should we change y into f to the negative 1 of x, or the f inverse of x? Well, it depends on if this is a function, if it passes the vertical line test. So if you grab the graphing calculator a minute, and I will do that as well. Okay, and in our y1, we put the cube root of x minus 4, and then hit graph. And look, there you go. There's our function, or there's our graph. And if you look, a vertical line would only ever pass through that graph once. So therefore, we can say that this is a function, and that means that we can use the function notation for the inverse. And there we go. There's our final answer. Okay, next page. Consider the function f of x equals x squared minus 4. Graph y equals f of x on the grid below, or provided, and state the domain in the range. Okay, so we should graph that if you want to graph your graphing calculator, and then once you figure out the graph, put it back on this. You can also use your skills with quadratic functions from 20-1. So x squared minus 4, that should be a parabola. Okay, it should have a vertex at 0, -4, and it should open up because the leading coefficient is positive in front of the x squared. So it's almost easier to do it that way, isn't it? Okay, so 0, 4. Now, I suppose if we wanted to get a little more accurate, we could, but I'm just going to sketch this in here. It would probably look something like, there we go. Okay. There we go, something like that. All right, and I'm just going to label that f of x equals x squared minus 4. All right, state the domain and range. Still have to do that for that graph. Okay, so looking at that graph, domain, we would say, is x such that x is known in the reals. Our graph goes forever left and right. My curly brackets are getting worse and worse. Okay, let's try that again. Okay. All right, range, all possible y values. Let's take a look. Well, the graph doesn't exist down here, so the lowest y value is, and watch your scale here, every square is worth 2, so we would be at -4, and then it's everything above that. So we'd say y such that y is greater than or equal to -4, and then just tack on y is known in the reals to keep the real numbers. All right, so we're going to determine x equals f at y. So they're basically, this is their way of asking for the inverse. And they're already telling you not to use that function notation by writing x equals f at y. So let's go about doing that. We're going to start by writing y equals x squared minus 4, our original function, replacing f of x with y. Okay, switch x and y becomes x becomes y, and solve for y. Add 4 to both sides. Get rid of that. X plus 4 equals y squared. And get rid of the square by square rooting both sides. And we would have y equals the square root of x plus 4. Okay, now I've missed something there. When you square root both sides, you should have a plus or minus in front of that square root. And the reason why, if you think about this, let's say we had something like x squared equals 9. Okay, when we're square rooting both sides, so if you square rooted both sides here, you'd think the answer was 3, right? Okay, really what we're looking for is what number, when you square it, gives you 9. Well, 3 works, but guess what? So does -3. And that's why you need to write plus or minus here. Okay, so there we go. Solve for y, x in terms f at y. Wait, do we do it that way? X equals a function of y. It could be they didn't want us to solve this because x equals f at y. But the only thing is we would have a hard time graphing the inverse. We're going to go with this is fine. Oh yeah, they said solve for y, so we're okay there. Now, graph the inverse of f of x. So we need to graph this particular relation on the grid provided and state the domain and range. Okay, now this is actually two functions. If you're to put this in the calculator, it needs to be as root x plus 4, but it also needs to be negative root x plus 4. Okay, so that's how you would get both appearing on your graphing calculator if you were to do it that way. Okay, so let's get that graph on our grid, and then we'll talk about domain and range. So pause the video. Maybe you're having trouble graphing this. Let's take a look. Remember, we can use this point in particular, which we know is 0, -4, right? And to find the inverse, switch the coordinates, -4, 0. So we know there's a point there. Okay. You can get some other important points from your graphing calculator, or this point here, 1, -1, so -1, 1. Okay, and we've kind of got that idea going on. So this would be y equals square root of x plus 4, but we also want the negative, right? And that would basically be this part here. And it should be a reflection like that. There we go. That would be our negative root x plus 4. And together, those make up the inverse, the plus or minus root x plus 4. Okay, let's talk about domain and range. Okay, domain. All right, we're looking at this red graph, and we're looking at the possible x values. Well, no graph over here, so it looks like x can be greater than or equal to this number here, which should be -4. Okay, so we're in x such that x is greater than or equal to -4 and an element of the reals. Okay, range. Okay, so we're looking at the y values. Now this graph actually goes forever down and then forever up. So guess what? Y is an element of the reals. All right, looking good. Is the inverse of f a function? So in other words, is a vertical line passing through it more than once? For one value of the domain, is there more than one value of the range? If so, it's not a function. And look at that, vertical line, sort of vertical line, passes through more than once. So not a function. Okay. Then it asks, if not, how could the domain or range of f, the original graph, be restricted so that the inverse of f is also a function? Okay, well this is kind of interesting. So what they're saying is, how do I restrict the domain on the blue graph, the original, so that the red graph is a function? Well, to make the red graph a function, we need to get rid of one of these branches of the parabola. Let's say this branch. Okay, now that branch, if you think of reflecting it over the line y equals x, would correspond to this branch on the original. So in other words, to get rid of this branch on the inverse, we need to get rid of this branch on the original. To get rid of this branch on the inverse, you need to get rid of that branch on the original. Okay, so that means our domain would have to be restricted to just get this right side of the parabola. Okay, so to do that, we would have to say x is greater than or equal to 0. And then we could do the full set notation if you like here. Okay, there you go. Got rid of the lower branch of the inverse, which corresponded to the left branch of the original, by restricting the domain to x greater than or equal to 0 from this point to the right. Okay, let's look at example 4. Don incorrectly determined the inverse of a function defined by the root of x minus 3, y equals the root of x minus 3, to be the equation of y equals x squared plus 3. He graphed the inverse and obtained a parabola, inverse of the function. Explain why Don's equation of the inverse is not complete and why the graph of the correct inverse is not a parabola. Okay, so I determined the inverse of the function defined by y equals the root of x minus 3. Okay, so how about we follow through and see where he messed up, okay? So you guys take this equation, okay, and switch x and y, solve for y, and see if we get what Don did, okay? So go ahead and pause. Actually, we're getting close to the end of part 1 here, so why don't we finish this example in part 2, and I will see you there.